changing climate needs a cure. Help me if you can, oyster growth is down. Water quality's declining all around. Help me make my oyster reefs abound. Won't you please, please conserve? And now my system's changed in oh so many ways. Our oysters seem to vanish in the haze. GLOBE teaches others that education is the cure. Conservation's needed like it's never been before. Help me if you can, oyster growth is down. Water quality is declining all around. Help me make my oyster reefs abound. Won't you please, please conserve? Conserve, conserve, conserve.
For centuries, a vast network of oyster reefs fed the Chesapeake Bay's people, cleaned its waters, and protected its fish and crabs. The name Chesapeake means Great Shellfish Bay in the language of the Algonquin Indians. But by the 1920s, dredging for oysters had removed 3/4 of the bay's life-saving reefs. The surviving oysters were nearly eradicated in the second half of the 20th century by disease, pollution, and continued over-harvesting. Oysters are very important to the economy of the area. Large oysters can filter up to 2 gallons of water in an hour during warm summer months, removing sediment and phytoplankton in the process. In small, shallow areas, the return of oysters could significantly improve water clarity as they filter algae and sediment from the water, potentially allowing a return of underwater grass beds. Oysters provide employment and food for many people. Goal: determine how gradual climate change could impact oysters in the Chesapeake Bay watershed. Experiment: compare growth of oysters deposited in different bodies of water with different water qualities.
Our hypothesis was if temperatures rise due to an increase in carbon dioxide in the air, then water quality will decline and oyster growth will be impeded.
We acquired young oysters called spat. The spat is about 2 weeks old and very vulnerable to be eaten by aquatic creatures. We protected this spat for 7 months. They were then to be returned to the watershed. We received the oyster spat in lots of 2,000. The oysters were put in floats at 4 different locations. Water quality was tested monthly and oyster growth measured. The results were compared with data from each location.
4 locations participated in this experiment. Northampton on the eastern shore was closest to the mouth of the bay. Back River is on the northern part of the peninsula. It is the shallowest area. Leeward Marina is on the opposite side of the peninsula. It's nearest the school. And finally, Hoffler Creek is in a very populated area, and it's the southernmost part of our experimental area.
Salinity is the amount of dissolved salts in the water. Oysters prefer brackish and salty water with a salinity range of 10 to 28 parts per thousand. If salinity drops below 5 parts per thousand for an extended period of time, oysters will die. Salinity is measured by looking through a reef rapsometer.
pH is the measurement of hydrogen ions activity. The pH scale ranges from 0 to 14. Oysters prefer to live in 6.75 to 8.7. Neutral pH is around 7.0, and anything below is acidic, and anything above is basic. Rainfall or soil lower or raise pH. CO2 in the air dissolves in water to make it acidic, which could harm oysters. Amount of pH is tested using tablets. Dissolved oxygen is the amount of oxygen in the water. Cold water holds more oxygen than warm water. This is measured in parts per million. The levels of 5 to 6 parts per million are needed for most aquatic organisms to grow.
This is another view of where
Oyster growth. The oysters in the Back River in Poquoson had the greatest growth, followed by these at Leeward Marina and Newport News. Salinity versus size. Salinity at Northampton was much greater than any other place, and it had the least growth rate. Temperature versus size. Large temperature fluctuations, difficult to compare because the measurements were not taken on the same day. pH. pH varied between 7 and 9. Hoffler Creek had highest pH and least growth. Dissolved oxygen. Poquoson had most growth and most dissolved oxygen. If climate changes occur, dissolved oxygen will decline due to the increase in pH and salinity.
Conclusions. No actual conclusions can be drawn. However, a few observations can be made. Growth was better in moderate salinity and acidity. It seemed to prefer a constant level of both. Growth was also better when dissolved oxygen increases. There are several sources of error. First, our measurements were not taken on the same day. Some were taken at the beginning of the month, others at the end. Different tides and so forth would affect those. Turbidity was not considered. Water depth was not constant. Some of our locations had much deeper water than others. Water flow rates were not considered. This would impact how much food actually passed by the oyster. And then tides were not considered. Next year, we'd like to continue oyster gardening, but this time we'd place multiple floats at the same location. This would allow us to determine if it was just the particular batch of oysters that grew faster or the location affected it. We'd closely monitor the mortality of the oysters and track air and water temperature for each location.
Oyster release. Working with Chesapeake Bay Foundation, we planted oysters on a protected oyster reef in the Elizabeth River. We traveled by boat to the site and dropped the oysters overboard to the reef. We also planted some of our oysters on a protected reef in the York River, another tributary of the Chesapeake Bay. This reef is located in shallow waters, and, as you can see, we were able to wade out to the reef during low tide.
Thank you for your help.